This is lesson 3-3, the percent equation, and it starts in your workbook on page 156. This is example number 1 on page 156. It says, in science class, students compared their vertical reach and height to see if they are proportional. Maria is 60 inches tall and can reach 75 inches in height. What percent of her total vertical reach is her height? And this time, they want you to use something called the percent equation. So we have our lovely bar graphs here, and we know her height is 60. We know her vertical reach is 75, and we know this bar is going to be her total 100%. So back in the day, we used to use a percent proportion. She is 60 inches out of her 75 total reach inches, and we want to know what percent is that out of 100. And you could cross multiply and divide for that. That was last lesson. Well, this lesson, they want us to use this framework right here. So we're going to use the we're going to use the part, which is 60, equals the percent, which is we don't know, times the whole amount. Okay, so this is technically a one-step equation. So I usually use a balance like you would have in science class to show that I need the same amount on both sides. If I don't have the same amount on both sides, it's going to be cattywampus. So I would like to get rid of this multiply by 75 because I really want the x to be by itself. So to get rid of a multiply by 75, I'm going to divide by 75. But if I mess with one side of my balance, it's now cattywampus until I do exactly the same thing to the other side. This cancels. 60 divided by 75 is 0.8. Bring down my equal sign, bring down my x. But you have to be really careful because they're asking for a percent, and this, my friends, is a decimal. So if you remembered when we had changing a percent to a decimal, we moved our decimal 2 places to the left. If we're going to go the other way, decimal to percent, I'm going to move my decimal 2 places to the right. 1, add a 0, 2, plop it down. That is 80%. All right, this is example 1, the try it, on the bottom of page 156. So we have an elephant that weighs 15,000 pounds on Earth, but only 2,500 pounds on the moon. Assuming the weights are proportional, what percent of its weight on Earth is its weight on the moon? All right, so we are focusing today on the percent equation. So if you remember, we had the part, whoops, let me get a marker instead of a highlighter. We had the part equaled the percent times the whole amount. Now you're going to notice I'm not using their boxes because their boxes and I don't get along very well. So the part it weighs on the moon is 2,500 pounds. I don't know what the percent is, but here on Earth, the full weight is 15,000. This is a one-step equation. I would love for this 15,000 to go away so that my x is isolated. So I'm going to do the opposite. The opposite of multiplying by 15,000 is dividing by 15,000. But if I only do it to one side, my scale gets all weird, so I have to do it to the other side. 15,000 divided by 15,000 goes away. I'm going to bring down my x. bring down my equal sign, and I have to use a calculator for that. 2,500 divided by 15,000 gives me a decimal. But do you remember how to change that into a percent? We're going to move it 1, 2, move that decimal 2 places to the right, and my final answer is 16.7%. This is example number 2 on the top of page 157. It says many states have a meal tax that is proportional to the total spent on food and beverages. In one state, the meal tax is 8.44%. And we want to know how much tax will a customer pay if the food and beverages total $54. So let's look at this. Remember this whole thing here where we had the part equals the percent times the whole? Well, the part is the tax. The percent is 8.44%, and the bill is 54. Now, the nice thing about this one is that when you have all of your numbers on the same side of the equal sign, you don't have to do that algebra stuff. If it says take 8.44% times 54, then just take 8.44% times 54, and you will get your answer. But be super careful, because remember, in our money system, we can only have 2 numbers after the decimal, not 4 numbers after the decimal. So you have to look at this next number after my cut line. If it was a 0, 1, 2, 3, or 4, you just trash it. It's not big enough to worry about. But if that second number, or that number after the split line, is a 5, 6, 7, or 8, or 9, then you have to go up. And that's why they rounded to $4.56. This is example 3 on page 157. It says Jane earns 5.5% commission on the selling price of each home she sells. She earned $9,020 in commission on the sale of a home. We want to know what was the selling price of the home. So here we go again. Part equals percent times whole. The part she earned is $9,020. The percent is 5.5%. Now, they could have left that just as 5.5%, but they changed it into a decimal, which is fine. I'm going to write this off to the side because I don't have room for where they were working. So they had $9,020 on one side of the equal sign, and they changed that percent into a decimal on the other. Now, my numbers are not on the same side. I can't just multiply them. When they are separated like this or divided from each other, that should give you a hint. If I want H to be by itself, I have to get rid of this number. Right now, I'm multiplying by 0.055. The opposite of that is dividing by 0.055. The numbers are divided, and I divide in order to solve. But if I do it to one side, I must do it to the other, otherwise my balance is no longer level. 0.55 divided by 0.55 is 1H. And $9,020 divided by 0.55 gives us the $164,000 house that they were talking about. So if my numbers are both on the same side, just multiply them. But if they are divided, one's on the left and one's on the right, then you have to divide to solve the problem. All right, this is the try it at the bottom of page 157 under example number 3. It says, to make a profit, a clothing store sells board shorts at 115% of the amount they paid. of. How much did the store pay for the board shorts? We've got one more piece of information right there. All right, so do you remember this? Whoops. You get a pen instead of a highlighter. We have the part. We have the percent times the total. But I also want to tell you they spent 115% of something. So 115% of some number is 28. All right, so I'm going to change this into a decimal. Looks like that, times some number. Our numbers are divided. I have one on the left and one on the right. So that means I'm going to divide to solve my problem. And I want to divide by this number. That way my x will be by itself. 1.15 divided by 1.15 is 1x. Looks like that. Bring down your equal sign. And then if you take 28 divided by 1.15, you're going to get a crazy number. Oh my gosh. Do I even have room for this craziness? I'm going to run out of room. Blah, 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 blah. Okay. In our number system, we can only have two numbers past the decimal. So I'm going to look at the 7, and I'm going to ask myself, is it small enough to throw away, or is it big enough to round up? And I think it's big enough to round up to $24.35 for our final answer. All right, this is our key concept on page 158. The percent equation shows how a percent relates proportional quantities. The percent is a constant of proportionality, and the equation has the same form as y equals mx. So we're going to use this, and it's kind of a fill in the blank type of thing. Put the part, put the percent, put the whole. Now if both numbers are on the same side, you're just going to multiply. But if they are divided, one number's on the left and one number's on the right, if they're divided like that, you're going to divide to find your answer.